Welcome to our P.D training video on Electron Aperture Digitization. So to start, what we need to do is import our file once we've scanned our electron aperture image. So I'm going to go to the P.D planning menu. I'm going to click Create Import Plan, and I'm going to choose the type of file that I want to import. Well, the last thing I happened to do was also a electron aperture block, so that is selected for me, but make sure you select Create Plan from Block Image, click Next, and now we need to enter the information for the patient that we're going to create. So I'm going to enter my patient name, I'm going to enter the medical record number for that patient, and I'm going to give a name to this particular plan. Okay, and then we need to select a treatment machine. You can use the dot decimal example machine or whatever machine you have available in your selections. Then we need to actually find the scanned images that we have created. So we click the Add Blocks button. That's going to bring up a browser for us to find those images. So browse to your image repository. I just have mine on the desktop here, and open your image, and you'll notice P.D will accept bitmaps, JPEGs, or GIF images. So I find my image, and I can open it up, and you can select multiple images here. If you select multiple images, they'll all appear in this list, and you'll need to go through this list and assign a beam number and a beam description to each one of these. When P.D loads these, it's going to load them in the beam number order that you give it, and it's going to provide this beam description as the name of the beam for each one. So if you have multiple scans, beam 1, beam 2, make sure that your description and your numbers make sense so you can understand which beam is which, because that will be important when you order your parts to make sure you treat the right field with the correct part. So we click Create, and now P.D is loading in that image file and preparing our patient and plan for us. So make sure that you have the Open Patient when finished checked, and we're going to go ahead and select Finished. If you happen to not have that checked, you'll notice the patient does appear at the top of the recent patients list, so after you're done, if it doesn't open for you, you can always go ahead and click that and it will open the patient for you. Then you'll notice that my plan is created. A beam is created using the description that we just gave as the name of the beam, and we'll see that there's this block image that's created in the patient tree view. We can't do anything with this block image. It's simply a placeholder to denote that a scanned file has been saved with this particular beam. And you'll notice whenever there's a block image present, this digitizer wizard will now be enabled. And that's what we're going to use to create our file that P.D can recognize for creating the electron aperture. Okay, so I'm going to start the digitizer wizard. Before I do that, I want to mention a couple things about the scanning process. I'm going to open my actual scanned image here. So this is the image that I got directly out of my scanner. So you'll see that some of the writing appears backwards. It depends which side of the aperture the writing and the drawing was on. Feel free to have notes, have whatever you need on this block that's important for your clinic or your facility, but make sure that within the contour region you try to keep that area clean and crisp, because you'll see that within the digitizer wizard it's going to make it much easier if there's not any writing inside of the block cutout field for us. Make sure your line is as dark as you can, and make sure that if you are digitizing and you're not the one who's also drawing the images, make sure that you understand which side of the image you need to be digitizing to. And we'll kind of see that as we go through today, but this line can be pretty thick, so make sure you know or you communicate with whoever drew these images. Am I discretizing or digitizing to the inside of the line, to the outside of the line, to the middle of the line? If there's any artifacts, any smudges or smears or places where the lines kind of blur as to where we should go, make sure you communicate with whoever drew that as to what this part of the drawing really represents. Okay? This is no different than what you would do if you were manufacturing these blocks in your house by pouring Cerabin, in your in-house, in your facility by pouring Cerabin. So shouldn't be anything that's too unfamiliar for those of you who have made these blocks in-house before. The key thing with the scan, make sure when you scan your image, the X minus mark is to the left and the Y minus mark is to the bottom of the page. P.D is going to require that it is oriented pretty close to that orientation. You'll notice my block is a little bit tilted in this scan. That's okay. P.D will take care of rotating it and scaling it for me. The critical issue is to make sure that we've scanned it in the correct direction, that the part is not upside down, because this was a clear template it's very easy to have it upside down. So make sure that your x minus is to the left and your y minus is toward the bottom. Okay? So we're going to go back to P.D, and as I said, we're going to use that digitizer wizard now to begin creating the block. So depending on what size resolution you use, you may need to zoom out. You can use the mouse wheel to do that, and you can right-click to pan. You may have to zoom and pan a little bit to get that image fully in the screen. Okay, you'll notice this image is pretty much pure black and white in P.D, so if the ratio of black to white is not quite what you expect, you can use this background level to adjust that and get a little bit sharper and crisper image for you in there. Okay, you'll notice a lot of times when this is up a little bit higher, you'll see some shadowing. Especially most scanners will tend to put a shadow on the x-axis. The y-axis is usually pretty good, but notice there's a double line on that x-axis. How do we know which one to use when that shadowing is caused? Well, there's two ways to do it. Typically, if you turn down the contrast a little bit, you'll notice the shadow is a much lighter feature, so it will disappear more quickly. If that doesn't work, or you're still not sure if the right one's disappearing, go back and look at your original image, and typically it's very obvious. We can see if we zoom in on this x-axis, the shadow is clearly above the actual x-axis in this case. All right, so we want to use the bottom line in our scan. All right, so if this is up to where we can see both lines, we want to make sure we're using that bottom one. I'm going to go ahead and turn that down to where I only see the one line, because the rest of my drawing then becomes pretty clear as well. So I'm going to select the machine. Well, typically we do this on import. There's no reason to change the machine again. There's only one beam in this case. If you're treating with multiple electron fields, you might have a couple beams that you imported for this patient, in which case you'll decide which beam you want to digitize. And then you need to select a size for the applicator. And when you receive these scanning templates from Dot Decimal, you'll notice the size is engraved on them. If this is unable to be read in your scan, if you drew over this or for some reason this just isn't clear enough and you can't see the scan, it'll be very obvious if the size is wrong as you go through the process. So if you don't remember the exact size, do the best you can to guess, and you'll notice that you really can't get it wrong, because when we're done with this orientation process, it won't look right. So this is a 20 by 20 field. The orientation process is very important, so we want to make sure that we get this right, because this is going to rotate and this is going to scale the part for us. P.D does not know the resolution that your scanner used to create this image file, so it's important to get that scaling right. So I'm going to zoom in, and we'll see once I clicked that start orientation, it told me what to do. Click the origin. Well, the origin is the center of our crosshair, so I'm going to zoom in and click on the middle of that crosshair. I'm going to zoom back out. Now it says click the X minus mark. I'm going to zoom in, and I'm going to click that X minus mark where it crosses the axis. Now it says click the Y minus mark. I'm going to zoom out, zoom back in on my Y minus mark, and I'm going to click on my Y minus mark. All right, and then we'll see when I pan and zoom here, P.D rotated this part for us and now aligned this outside edge with our actual part. So if we selected the wrong size, and I'll go ahead and do that real quick, if I accidentally selected the wrong size and I start orientation, I'll just do this quickly, not quite as precise, you'll notice the outside doesn't line up with my part. Okay? The scale isn't right. These tick marks are designed in such a way that if the size is wrong, it won't line up with the outside edge of your part. So that's kind of a fail-safe to help you know that you got the size correct. So I'm going to change back to 20 by 20 and redo my orientation. So I'm going to zoom into that middle crosshair, click that middle, zoom into my X minus, click that middle, zoom into my Y minus, and get that middle. Alright, so once I'm happy that my orientation looks good, that the blue lines that P.D draws as the guide line up almost exactly with my crosshairs that were on my image, and the outside lines up well enough that I'm sure that I selected the correct size, we can move on to actually adding the points. So now we have two options to add points, filtered or just regular. The regular add points is going to add points exactly where I click on the screen. Okay, so if you zoom in a lot, you want to get some fine detail, add points is great. Delete points allows us obviously to just click on a point and get rid of them. this add points filtered allows us to click close to an area where there's a black pixel. And you'll see I don't even have to get that close, and it's going to snap to the nearest black pixel that it finds. Okay? And if you have a very good scan and you use a nice contrast selection, because this will update with the contrast selection, you can create this block very easily. But you'll notice if there's extraneous marks on the inside of your contour, like this region, when we click, we might actually get the crosshair. We might get an area that's maybe not quite what we would expect. We get that tip, and that's not really what we want. But usually this add points filtered we can use to kind of just get the general shape for our part. And once we get kind of the general shape, what we typically do is we can zoom in here and we can start clicking a little more accurately, and notice that it'll snap to those edges pretty well. So as I go along, maybe I need an extra point here, and you'll notice I'm not even clicking on the black, and it's snapping right to that inside edge. So if you communicate with the person drawing these blocks that it's much easier to snap to that inside edge, you'll find that you can do this process very quickly. If I don't like a point that came in, remember we can always select delete and delete any points at any time. If I want to get a point somewhere on this black curve and I'm just not sure what the filtered points are going to do, I can use the regular add points and put the point exactly where I want it to be. And it'll go exactly where I click without snapping. Okay, I'll go back to filtered and add one more in there. Need to get a couple more over in this region. And here, well, I need to make sure that I communicate with the drawer of this contour. What do I do where these two lines kind of diverge here? Well, I've communicated with that person that this inside was just kind of a goof up, that they didn't erase. So they actually wanted this to stay on the inside. So I'm going to go ahead and use just an actual point to stay on the inside like that. Then I'll go back to filtered and finish up the next couple points here. And again, we've got a bad point where that crosshair is, so I need to delete that one. I can go back to filtered. And add a few more in here. Okay, and you'll notice in some of these areas I've been clicking heavily. I've been trying to make sure that everything's good. What else you can do, and on this second half of the contour I'll do this a little differently. I'm going to get rid of this extraneous point, so I'm going to delete him. And I'm going to make sure my contour is somewhat reasonable. So I'm going to get rid of, or I'm going to add one more point in here to make sure it snaps where I want. And then we have this option to autofill points. And if we zoom out a little, you'll kind of see that the number of points that we have in different areas. What this autofill is going to do, between every single point that you already have, if the spacing's not too small, it's going to add another point. So when we autofill, we're going to see that we get new points added that snap to the nearest black pixel all along the contour. So in the areas where I've already done a pretty good job following it, notice it did a very great job of following what I had already done. It finds the nearest black pixel and splits those lines. In areas where I wasn't so close yet, it still did a pretty good job. Okay? If we stay zoomed in, if we do this again, we'll notice some of this white space here is going to go away if I autofill points again. It's going to put another point in between all these, and it's going to start snapping to the curve pretty well. So I don't need to click all the way around if I don't want to. If there's an area maybe right here that just didn't quite get enough, I can go back and maybe add a point here and here. Maybe I still don't quite like what's happening here. I'm going to add one more there, and I want to get rid of this middle one and just bring him up a little bit to about here and here. And once we're happy with the curve that we've got, once we're satisfied that the curve in P.D represents the clinical block that we want to create or have manufactured, we just go ahead and click Finish. Okay? So if any time we can add filtered points, which remember snap to the nearest black pixel. We can add points, which go exactly where we click. We can delete points by clicking on them. And we can use this autofill points, which will add points in between every existing point we have. Okay? So once we're ready, we go ahead and we click Finish. and P.D creates the block for us. So we see this is our aperture block that we're going to get created. P.D in 3D doesn't render all of the chamfers and shapes. Each block can be slightly different in the way it looks for different machines, different linear accelerators. So we just use a generic square to hold the shape of our electron aperture block. So that's the process of digitizing an electron aperture. We're now ready to go ahead to the order wizard and order our part. So if you're unfamiliar with the order process, please see our other videos. Once the part's created like this, ordering it is just the same as any other part that's been brought into P.D.